y'all decide on one realtor and tell the realtor, here it is, here's what we want. He'll call you with offers, and then you just.
My name is Macy Hill, and today we're doing Lab 6 of my General Chemistry 2 lab. And we're going to do exercise 1. There's only one exercise to this lab. It's called Determination of Ka. And we're going to start off with part 1, which is determination of the equivalence point. So let's get started. So the first part is to measure 4 milliliters of the unknown weak acid from the dropper bottle. So we have the unknown weak acid right here, and we measure 4 milliliters into the graduated cylinder. So it needs to be at this point on the graduated cylinder. So let's measure 4 milliliters, and then we put it into the glass beaker. And then we place the beaker onto a clean sheet of white paper, which we have right here. So let's get started. So that is exactly 4 milliliters of the unknown solution. So now we put it into the graduated cylinder, into the beaker. Make sure all of it goes in, every drop. Alright. So now we add 2 drops of phenolphthalein into the unknown solution. So we take this short stem pipette and add 2 drops exactly phenolphthalein into the solution. Okay. Now we transfer it back into the solution. Alright, and now it says to carefully swirl the beaker to completely mix the unknown weak acid in the phenolphthalein solution. So the solution should be colorless and clear like it is now. So we mix it a little. So we'll take our other pipettes. So it says to carefully remove the cap from the bottle and remove the dropper insert from the top of the bottle. And then we gently bend the dropper tip to the side and move back and forth to separate the tip from the bottle. And then we place the tip to side of the bottle, leaving the bottle of NaOH open at the top. So now we place the tip of the empty short stem pipette into the sodium hydroxide bottle once we do this, and fill the pipette with the NaOH. So first we get rid of the plastic, so I'll go ahead and do this and then we'll continue. So I've gotten rid of all the top of the sodium hydroxide. So now it's just like a clear top right here. And I've got a new short pipette so there won't be any contamination. So we fill the pipette with the sodium hydroxide. So let's go ahead and do that. And now we add from the pipette into the beaker containing the 4 milliliter of unknown weak acid, 1 drop at a time, swirling, exerting the solution in the beaker after each drop, and then until the color changes into a pale pink color for at least 5 seconds. So we count each drop of sodium hydroxide added to the beaker, so we will know exactly how many drops of sodium hydroxide were required to cause the solution to change from clear and colorless to the pale pink color. So I'm going to add, make sure none of this leaks. And I'll add drops until it turns into that pale pink color. So that's 1, 2, 3, 4. I'll mix it up a bit. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So I would think it would. So now we repeat steps 7 through 14 in order to get the data for child 2. So we need 4 milliliters of the unknown solution once again. So that is 4 milliliters of the unknown weak acid. And I've cleaned this beaker, so there wouldn't be any contamination. So we now place it in the beaker. Alright, and let's see how many drops. So we add exactly 2 drops of phenylethylamine solution again to the weak acid in the beaker. So here's the solution we're adding, exactly 2 drops. Alright, make sure it doesn't leak. Alright, now we'll add 2 drops exactly. So that is exactly 2 drops. Now we'll put it back into the solution. Alright, and then we'll give the solution a swirl so it will be mixed together. And now once again, we'll be counting the total drops of sodium hydroxide to determine when it becomes a pale pink color. And then we'll add it to trial 2. So let's start. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So from this position, it looks like it's already pink, but I'm trying to have like the entire solution become like that pale pink color. So I'll show y'all. So the entire solution has become that pale pink color and is once again taken 30 drops of NaCl in order for the entire solution to become that pale pink color. So I'll add into the data table and we'll move on to the next part of the experiment. So here are my results from data table 1. And now we'll move on to part 2 of the experiment. It's called the construction of pH triation curve. So I've gathered 4 milliliters of the unknown weak acid once again. You're gonna place all 4. Okay, so we will place like 4 of these pH circles into there. Make sure all 4 of them touch, and then we will use this to determine the pH of the weak acid. So let's make sure. Alright. So let's see what the pH of this is. So it would probably be around 2 or 3. I would probably say right now it's closer to 3. So that's the pH of the solution, and let's see what's next. So now it says to add exactly 10 drops of sodium hydroxide into the beaker. So we will calculate exactly 10 drops of the sodium hydroxide into the unknown weak acid solution. And then we swirl the beaker afterwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, now we swirl the beaker. And it says gather a pH strip from the kit and place it into the solution, and we'll determine the solution of it with 10 drops of sodium hydroxide. So let me cover this up. Alright, and then we gather from a pH indicator. And we'll determine the pH with 10 drops of sodium hydroxide. Alright, so here we go. So here's the results, and now we'll so I believe this has the closest on pH this has is a 4. It's between a 3 and a 4, but it's more closely to a 4. So here's what it looks like. So, and we record this in the data table too. And then we repeat steps 26 through 31 for the remaining 13 triation steps in data table 2. And it says it's important to collect the pH at exactly the number of drops required to reach the half equivalence point in the equivalence point. So I've done the trial 2 times, going all the way to 120 drops of NaCl. And here's my results for that. So for the half equal point, I got the pH of 4 and 2.5, and the average, which is also the pH for this acid, is 3.25, a pH of 3.25, and the equilibrium point is around 4.5 average. So I've determined this to be the closest pH to this is monochloroacetic acetic acid, which is a 3.87 pH. And I've determined the Ka value of inversing the log, which is 10, and it's the negative pH, which is negative 3.25, which is my pH that I've gotten. And my Ka turned out to be 5.62 times 10 to the negative 4. And so we need to find the percent errors in this. So I've used the Ka value for monochloroacetic acid, which is 1.35 times 10 to the negative 5. I used the Ka value minus the Ka value for mines, and I've gotten a 58% error for the Ka value. And for my percent error for my pH, I did 3.87, which is the KH of Ka of monochloroacetic acetic acid. And I've subtracted it by mines and divided it by 3.87, and the percent error came out to be 15%. So that is the end of my lab, and I hope to see y'all guys next week for another.